All right, good morning, everyone. Can everyone hear me okay? Time to turn it up. How's that? Better? Yeah. Yep. All right. I think so.
Everybody in the back?
Good. This is good? This is better. All right, we'll move it up closer to my mouth. All right, good morning. Good morning, everyone. So, Greg Belanger, I'm with LG, KU, and PPL. I am the Chief Technology Security Officer. Today, I'm going to be talking about securing AI in your company. We've all heard a lot about tools that are security tools that have AI in them, but you may or may not have been asked, how would we secure AI in our environment? So let's do a quick survey, if I could. How many of you don't have AI in your companies? Show of hands. One person doesn't have AI. Is that Megan? That can't be true. All right. How many of you allow your end users to go to public AI sites like OpenAI, Claude, etc.? Okay, a few. How many of you are leveraging things like Wiz or other tools that have AI built into them? Pretty much everyone, right? How many of you are using tools like Azure OpenAI or Google Vertex? Good. How many of you are using AWS Bedrock or have downloaded a model from Hugging Face? Okay. And then how many of you would say either part of your responsibility or your full-time responsibility is dedicated to being an AI security person? 1, 2, all right. So the hope today, this is my goal today. I've been doing a lot with AI for, 14 years, right? And it's gone and it's really evolved the last, say 2 or 3 years. It's gotten pretty intense with Gen AI and things like that. So the goal for me today is, A, bring you guys up to speed on some of the newer concepts. And then if you've ever been asked by your CISO or your CIO or your CEO, how would we secure AI if we're using AI? You probably have teams of developers who are looking to take advantage of things like Azure OpenAI or build an application on AI. How would you go about securing that? And you're probably asked, what kinds of tools should we buy or what kinds of things should we look at? So I hope to give you at least some baseline security controls that would be very cost affordable and available for you right now and bring everyone up to speed on all of that. So that is the mission for today. All right, so here's what we're going to try and cover in the next 50 minutes. There's going to be a lot. It's going to be intense.
I can't hear you in the back.
Really?
Yeah, I think this is not working. Let's see if we flip that a little bit. Let's try to do that.
Any better? In the back? You guys hear? All right, sweet.
Perfect.
All right, very good. All right, so this is what we're going to try and cover today. There's a lot there, and we'll go into some depth. Don't worry if you're, don't have to take notes or anything. We'll make it all available to you. But there's a ton of resources at the end, and we'll try and give you all those resources. So first things first, who am I? Currently the Chief Technology Security Officer at PPL, LGE, KU. We're leading enterprise security initiatives. I am responsible for securing AI in our environment. At PPL, we're doing a lot with AI. We're investing in things like AWS Bedrock, tools, digital assistants, agentic AI. So we're pretty heavily involved at the forefront of this, and we feel like it has revolutionary potential for us. As well, we're also looking to power data centers and things like that that will support the next generation of AI. I've been the head of security engineering at CBRE prior to this role. I'm new to this role. I came in April, moved to Allentown, Pennsylvania. I came from CBRE where I was managing their security engineering environment, cloud, agile, things like AI. This framework that I'm going to talk about today was developed for Gen AI and in place currently at CBRE. And then I've done some training on this. There was a massive open course with Peter Norvig and Sebastian Thrun. Sebastian Thrun, if you don't know, was the guy behind Google's self-driving cars and things like that. So they did a free open course to try and raise awareness of AI. And that's my mission today is I feel like today there's not a lot of knowledge about AI concepts. And these are not difficult. They're difficult concepts, but a lot of the concepts for cybersecurity people are going to be the same. They're not going to be very different. So hopefully I'll put these in ways that make sense to all of us, and we can raise our collective AI literacy and talk about how we would secure these things going forward. So first things first, what is Gen AI? So Gen AI essentially creates massive models or large language models that in response to a prompt will give you some sort of creative output. How do we do that? How does it get trained? Well, it takes essentially lots of data and it puts it into a model architecture, and then it creates all of that text that you give it and puts it into a token, and then that gets put into values, and it's essentially going to take your responses and try and make sure that it gives you an accurate response. So that whole process is essentially creating weights and parameters. The weights are the secret sauce here. So if you're working at one of these companies like Claude or OpenAI and you're in charge of securing their environment, those weights are the closely guarded secrets. And you'll hear terms. There are models like OpenAI, which are closed weights. That means it's not available for manipulation. There are models like you can get from Hugging Face, which are open weights, which are open for you to make changes to and adjust, right? So you can fine tune those models. Think of it as there are open source and there are closed source. So some models are open source, some models are closed source. Make sense? So how do these things get trained? So this is the important part. This is a process called stochastic gradient descent. So when we put in all of these massive data files, these data files go through and they get put into classifiers, they get labeled, and then we give it prompts like, what's the capital of France? If it gets the answer right, it gets a reward. That reward increases its viability, and we adjust the weights. If it gets it wrong, we tell it that it got it wrong, and it goes back and retrains. So this process goes on basically all of Wikipedia, all of the internet. You can read all of those documents, and that training data set is pretty much the same across a lot of these models. The corpus of data that we give these models is pretty huge. And this is computationally expensive. So it's got to go through and run through essentially GPUs or CPUs and run these calculations. All of this is math behind the scenes to come up with, this is what we think is the best answer for the prompt that was given. And then based on the human analysis or some self-tuning, it can say, we got this, and we'll adjust our model weights. So think about that from a data perspective. All the data that goes into training a model gives it its weights. And if you're using a model, an important part of that is, where did it get trained? What did it get trained on? And what were the biases given to it? If I said, China is a great country, if you're in China training a model, that would be wow, that's a great answer. If you're in a US training country, it may not be a great answer, right? So the biases are going to be reflected in the place where these models became developed. So there is a lot of that. So some of the considerations. So the stochastic gradient descent. Stochastic means chaotic. It's random. So when we talk about things like hallucinations or things like that, sometimes it'll give the right answer. It's trying to get to an optimal answer, but it does that by guessing up and down the spectrum. As long as the vector is moving towards an optimal answer, essentially that's what we give it. We say that's the model weight. But it does that through random answers. And then over time, we fine tune it, and we get down to pre-trained models on domain-specific data, like security logs or documents. So we train it for a particular purpose. There's interaction layers, prompt engineering. We can talk about what prompts we give it and then we can adjust the model. So like I talked about, avoid bias, some of these things, become more involved. If you look at model output, it's shaped by what's the context of the question that was asked, and then tokenization, how many tokens can we give it before it runs out of memory, and then how many parameters could it be able to consider. So when we talk about something like Llama 7B, that 7B is 7 billion parameters. And when you think about, if I'm gonna ask it a question, there's only so much memory or tokens that I can give it before it runs out of memory. So if I said, let me put in a question that encompasses the entire internet, it would run out of tokens before it gave you an answer. Security implications for this, fine-tuning is very, very expensive. And you're having to give it a ton of data. So if you're trying to fine-tune your own models, that involves you giving a model a lot of data. That model now contains all those that data that you've given it. So if you've ever wanted to fine-tune a security model, all that data could be exposed. So that makes the importance of keeping those models safe that much higher, but it also increases our attack surface. Prompt injection. So there are ways that you can fool these models into giving up exactly what you want. That's a new attack surface. And then model integrity. How do we know that the model that was trained and given to us is safe to use? Where has it been? So why does that matter? Why does it matter now? You guys all know AI is everywhere. Everybody, we talked about Black Hat and things like that. There are tons of vendors, there are tons of tools, there are tons of models. Everybody's wanting to take advantage of AI, but we're not necessarily securing AI. So there's lots of directed services like OpenAI, ChatGPT, Google Gemini, and more. There's lots of custom solutions like Azure OpenAI, AWS Bedrock, where you can develop your own solutions. So the major providers, Microsoft, Google, OpenAI, and Anthropic, probably gonna be more, but it's hard to get to a serious, some of these models are multiple billions of parameters, and the hosting for these models and training of these models requires massive infrastructure. Enterprise adoption, this is my random figure, about 95% of the companies in the world are actually consuming some sort of AI model, and that creates all sorts of risks. So I believe there is a substantial gap in what we as security professionals know about AI at its fundamentals and how we would go about securing it. So, how to secure it? Basically, my thoughts on this, start with governance. You have to know what's in your environment before you can start to lock it down. At PPL, we have taken a process where every new use case for AI has to go through a governance review. Some of the technologists review it, and then some of the leadership reviews it, and then we approve it. So we have a sense of what's in our environment. This is key. Also, we're not gonna focus on things like good old-fashioned AI. Machine learning and AI has been prevalent for years and years. There's lots of tools out there. The more prevalent use case nowadays is Gen AI and agentic AI. We're gonna get into that a little bit. Build your own AI inventory. So I'm a big advocate for essentially take all of your applications. If you have an application portfolio management system, an APM, hopefully based on something like a CMDB, you can annotate whether or not AI is present in that system. And then I will tell you what I'm thinking, we classify AI in about 4 different ways so that we have an understanding of what's our threat surface for that particular AI, and then how would we go about securing it. All right, so the types of AI in the modern enterprise. Again, this is my viewpoint on things. I'm open to discussion on this, but what I see a lot of is indirect AI. So if you've got a tool like Wiz, and Wiz has a chatbot that's built into it, and it can help you use the tool better, that's a form of indirect AI. Adobe Firefly, that's another form of indirect AI. You can't change the underlying model. You can't protect the model. It's governed by the company who put it into their product. So that's indirect AI for all of us. That being said, it's like, think of it like SaaS today. If you're using Salesforce or ServiceNow, can you ask them, hey, let me put a WAF in front of your environment, or let me get some instant response from your environment? The vendors, we're trusting the vendors to do that for us. Direct AI access is, I want to go out and tie directly into a public AI provider, like an OpenAI, like a Perplexity, like Claude, and I want to either plug into their API, or I want to just use their chat interface, right? And with those chat interfaces, you can upload sensitive documents, you can have it write emails. There's a very famous leak about 2 years ago where Samsung engineers put in their drivers into ChatGPT and tried to optimize those drivers. That made ChatGPT have their code. And then somebody took that and reverse engineered that and was able to find out the code for those drivers. Pretty expensive mistake. But that's out there. And that is a high-risk area. Managed AI providers are things like Google Vertex, Azure OpenAI. Azure will host an instance of OpenAI, either a particular model type like a ChatGPT 5 or 4, some minis. So they'll host it for you. The model is closed, it's closed weight. You don't have the ability to put data into it. You can't fine tune it, and there are certain safeguards. Things to be considerate of. If you're building on top of that, all the data you're sending to that interface goes to that provider. And you can opt out of that. You can say, I don't want my data to be stored for any way or purpose. But for the most part, they default to, we'll keep all of your data for about 30 days for quality assurance to make sure if there's hallucination, we can figure out why. So all that data would go up there. And then the last one is self-hosted open models. So that's where you're taking something from Hugging Face, maybe hosting it through AWS Bedrock, hosting it internally. There are models that you can get off of GitHub, you can download, you can put those on your device. There are even folks that I know that are taking smaller models like Mistral and putting those on home devices, Raspberry Pi devices. There's a ton of options to host this. But think of it. This is a model. You don't know where it's been. You know what it was trained on. You know what it could do. If you're using it for code, is that safe code? Or is it not so safe code? There's a whole range of things. So those are some of the considerations. These are the types of AI that I see, for the most part, in large use. For the most part, I don't see a lot of us developing our own AIs, developing a model from scratch. We'd have to have access to massive amounts of data. We'd have to have massive compute infrastructure, and all of that is very expensive. There are companies who are doing this. So there are companies where they're developing their own proprietary AI. Sneak, for example, if you're familiar with Sneak and it does source code analysis, they have a proprietary AI that they're using to power their product. They're developing it. But for the most of us, we don't have to worry about that. These are the 4 types. And what I would suggest is classifying your applications that are using AI along these lines. This will help you think about how would I secure these environments. Common controls. So this is the thing. If you don't take anything else from this talk, these are the things that I want you to focus on. The biggest thing that you're going to get, the biggest thing you can do, is a thing called an AI guardrail. This is no different than the guardrail concept. When we went to the cloud, we put guardrails around things. Think of this as a WAF, DLP, API security model for your AI environments. This sits up in front of your AIs. It will filter all sorts of things. If somebody's trying to put in a malicious prompt to check out what data is in your environment or to make your application do something it shouldn't, this will protect you. If you're trying to upload sensitive data, this could block that sensitive data. If you're trying to drain the tokens from the environment, it may protect you against those token drains. So that's one of the most common things you'll see. Some of the platforms that are out there, Azure Prompt Shield, this is on by default with Azure OpenAI. So that's a pretty powerful tool. There's no additional cost for you to leverage that. Google has something similar. AWS Bedrock hosts something called AWS Bedrock Guardrails. It is not on by default, but it's something you can turn on. They'll charge you an extra fee for it, but it, again, provides you a lot of security. There are other platforms like Hera, Lasso, Pillar, Encrypt. NVIDIA has an open source guardrail called Nemo. Guardrails AI is also open source through GitHub. So you can do this yourself. But this is a very powerful tool that will front end all of the things that are going into your AI and coming out of your AI to protect your end users. So, human in the loop. This is another term you'll hear a ton about. Human in the loop is everything that goes in is checked in some fashion against ground truth and reviewed by humans. So think of it as when you go to the grocery store and somebody is scanning your groceries on a checkout. They're not actually looking at each and every grocery. They're just checking to make sure that the item matches what was scanned and that the price is accurate. And if there's ever like, hey, wait a second, this is the wrong thing. You know, it came up with oranges and I clearly scanned bananas. That's what human in the loop, that's that whole concept, right? But this is very, very powerful. You'll hear it talked about. So as your teams develop AI, as you're building out AIs in your environment, a key question to ask vendors is, what's your human in the loop strategy? How often do you review the inputs and outputs to make sure there are no hallucinations? You can check them against things like ground truth metrics, ground truth analysis. Sort of the holy grail in this space is human in the loop is a pretty expensive operation. We're having to go through and check on making sure that all of these inputs and outputs, you can only do a sampling of that. If you had an AI that could actually predict that it's ground truth, that would be a great thing. But AIs themselves are prone to hallucination. So it's a bit of a challenge. This is something that's being worked on actively, but human in the loop is a term that you'll hear pretty predominantly in the industry. The last one is token rate limits. So for all of you, you guys are all familiar with DDoS. These tools tokenize every input. If you give it a massive input, that's a massive amount of tokens that it has to generate. You can give it a massive input that would drain all the tokens out of the system. Also, for scalability, right, if you're hosting an application in your enterprise, you're building your own chatbot with Azure OpenAI, there's a limit on the amount of tokens that you're going to use, and you're going to be charged per token. So they put in hard limits to make sure the system remains performant. Now you can adjust those up and down, but token rate limit is your DDoS protection for your AI environments. So if you're not taking anything else out of today in my talk, these are the three things on by default, mostly free, that you can use to protect your environment. And this will give you that sort of 80-20 split on, this will cover you against most threats the modern AI environment will face. And you can ask all your vendors what their strategy is here, and you can implement these on your own. All right, the less common controls. Model scanning. So if you get these models, how do you know where they've been? How do you know what's in them? There are tools that are available that can go out and actually look inside the LLM itself, make sure that the data that was used to develop these are safe. Wiz comes with a great one. It comes with an AI, security posture management tool. If you're in a cloud environment and leveraging Wiz and you're doing AI work there, it can go out and scan the models that you're using and give you a relative score on safety. AI red teaming. Think of this as just pen testing for your models. These are people like HackerOne and others who go out and actively try and break your models, jailbreak them, try and do model inference attacks so they're actually seeing the data that was used to train your model, exposing private data, or stealing your secrets, getting your weights, and then being able to replicate that. This is a big area for a lot of the big companies who are developing AIs to make sure that no one goes out and steals their secret code. So this is a big function. Data poisoning protection. There was a company, won't name names, who developed their own AI for endpoint protection. And they were very public about, we're going to gather all these threat intelligence signals, and then we're going to have an awesome AI that will be able to detect polymorphic malware and things like that. Bad guys were aware that they were developing and consuming tons of data, and they put a particular poison pill inside of their data, and when it was trained, it skewed all the results in that model. All that time and effort wasted. So data poisoning is a big thing. Again, this comes back to know your inputs, right? This is a supply-side attack against your AI development. Custom safety filters. A lot of us will have what we call toxic term filters. If you try and ask it, how do I build a pipe bomb? Or, I don't like this particular minority group. It should filter those kinds of things as toxic terms, right? Those are things that, either go against community egress. OpenAI has a very, robust, toxic terms filter. those things can be put in, and you can adjust those for your particular industry. So I work in the utility industry. I may not want things that I would consider, security information around grid or BCSI or, bulk electric systems. I don't want that data going into my environment. I don't even want people asking about that information. So I could customize my filters to make sure that I exclude certain terms. Fine-tuning data encryption. So a big thing that you can do is you can take these models and you can fine-tune them for your particular purpose. But that involves massive data sets. How do you know that that data set hasn't been tampered? So fine-tuning data encryption is putting encryption around the data that you're using to train the models to make sure its integrity is intact. These are less common, but they are available, and there are lots of tools that could give you those if you're starting to get into developing your own AIs through Bedrock or things like that. So these are some of the regulatory and risk frameworks. Let me go back. So lions, tigers, and bears, right? The EU AI Act. If you're a company that works in the EU, this applies to you today. There are lots of rules and regulations around it, and it covers a whole wide spectrum of things. The OECD AI principles is more of an international equivalent of the EU AI Act. These are policies that you can think of that would govern you and how you would approach AI. NIST AI RMF. So this is a 4-pillar framework that will give you essentially some best practices about how do you look at your AI environment. So that's a very powerful tool. ISO 42001, if you're an ISO shop, consider using this for evaluating your AI environment and whether or not you're secure. And the last thing, the threat models. There are MITRE Atlas. MITRE Atlas is very popular. You're all familiar with the MITRE attack framework. This is like the attack framework for AI. NIST AI 601. So this is a derivative of NIST AI RMF. This is relatively new. This is a particular threat modeling framework that was given through NIST for people. The other one that I didn't include here, it's in the reference material. Ken Wang and the Cloud Security Alliance have developed a thing called Maestro, which is another threat modeling framework for using around AI and how you would govern that. So all of this helps us think about how would we secure our environment going forward. RAG. How many of you have heard of Retrieval Augmented Generation, or RAG? Couple. If you get an AI from the internet, it's been trained on the body of work from the internet, Wikipedia's, just a whole range of things. It doesn't know what is your particular, if I said, how do we govern, code in our environment? What's the name of our application that we should use for code checking? It doesn't know that. It can't see inside of our environment. So you have two options. You could either fine-tune it and give it your entire environment and then run it through a lot of computational cycles to make sure it's optimized and ready to answer your questions. Or you can add an external data source, SharePoint, database, flat file system, and you can give that to the AI. Essentially what this does is, hey AI, what's the tool that I should use for scanning my code? If it doesn't know, it goes out to this RAG data source, augments its response, and answers your question. So this gives you access to real-time information from your environment. And it gives the database, the ability to give even more accurate answers. LangChain and other frameworks, Weaviate, will give you the ability to connect in. All you do is you take your SharePoint, your flat files, your databases, and you put those into formats that your AI can leverage, what we call a vector. And you create a vector database. There are lots of things. There's Azure vector stores. There's a whole range of technologies that are used for this now. So as you guys all know, right, you're security professionals. I want to give my internal data sources, my SharePoint environments, my databases, I want to give access to the AIs to all of that information. What could go wrong, right? So this is a big thing for us. We need to look at, well, what are some of the components, right? Those data sources are out there for us. How do we connect into them? Are we exposing those externally now? What about vectorization? We've got to run those. We've got to periodically rerun the vectorization of that, make sure we have updates. All of that can be done through generation. And then obviously the users will come in and try and get access to that. The dangers here, if you don't control what users can see, and if you have too permissive a policy, all of a sudden you've got people checking out emails and all sorts of other sensitive information about your environment through your chat interface. So, agentic AI. Agentic AI is the hottest new thing. This has been around for about 12 months. It's been the trend. Agentic AI is essentially all of the things we just talked about with AI, but now you're giving it the access to tools and you're allowing it to take action. So agentic AI is essentially saying, great, I'm gonna give you, a job to do. Go book a trip for me. So instead of telling you, here's the things that I would do through a chat interface, the agent will actually go out, take your credit card, go out to a browser, go out to a website, book the trip for you. I had an example of this. I had a person book a 4-star hotel in Italy. Well, that's a clear violation of our policy. Why would you do that? We can't allow that. Well, the AI did it for me. Really? So how do I know that? Do I have any logs around that? So here's the way to think about this. You guys are all security professionals. These are digital employees. They're acting on your behalf. They have an identity. They're going to be running in your environment. They're going to be taking action on your behalf. They have access to browsers and to data and all sorts of sensitive information. But that's the way to think about it. These are digital employees. How would you secure digital employees? So here are the basic components, the building blocks of an agent, an agentic AI. A knowledge base, right? All of these agents have to have a brain where they can do reasoning. So that's another model that they use, an AI behind the scenes for that agentic AI. They have to have some sort of short-term memory. So it'll be tasked with something like, go out and book a trip for me. It has to remember that's my job. I have to go out and book a trip. So that's short-term memory. That's a persistent data store for that agentic AI. Tool access. You have to give it some ability to take action on your behalf. That's access to a tool, to a system, to do an actual action. And then it leverages an identity to act on your behalf. Do you want to create persistent identities that will remain forever? Odds are you're going to want to use ephemeral identities. Every single time this thing checks in and checks out to go and do an action, you should be using a credential or password that's automatically changed. And these things are going to be running millions of times a day. So you're going to want to have an infrastructure that can scale for ephemeral identities. So the core of this, essentially, you're taking a lot of reasonable inputs. There's a whole army of agents that could be acting on your behalf. Think about if you had this is a very popular use case, an agentic SOC. Now you've got a SOC that operates with agents, and they can do things like go out and analyze this website, go out and analyze this malware, look at the user's email patterns, document it all, send it back to an orchestrator who will then delegate to an agent that writes up a use case in your case management system, and then recommends actions or takes actions. Isolate the end user, remove the email from the end user's inbox. A lot of power here, a lot of potential. So, what are some of the things? So this is essentially the loop, the agentic AI loop. So it's an autonomous problem-solving system. Essentially, perception that gathers data from the environment, uses external tools. It can leverage LLMs to plan its strategy. But think about it, these LLMs that it's leveraging could hallucinate, could be getting it wrong, right? It maintains coherence. That's another big term. These things can only run for a period of time. The current record I think I saw the other day, an AI can only remain coherent for up to about 5 or 6 hours in general. With advanced systems, they can run for maybe 7 or 8 hours. So think about it as if you had a digital employee, that digital employee is only good for 7 or 8 hours of a workday, right? That's what this is doing. Except it executes decisions through tools, APIs, and systems interaction, and it leverages an identity to do it. So the real world example, an agent that automatically plans your business trip, queries APIs, books your tickets, there's all of that. So how would you go about securing agentic AI? This is no different than essentially securing digital employees, right? So think about it, what you'd want. I want to know exactly what actions they're taking at all times. What identities are they using? If you have something that does, URL analysis as an agent. That's its job. If it's in the HR database, that's a red flag. Your AI should be only doing URL analysis, right? So full observability is key, making sure you understand exactly what your AI agents are doing. This is not easy, but there are whole platforms being developed now to give you full visibility into what your AI agents are doing. Behavioral monitoring. This is insider risk management. It's UEBA, things we've been doing for years. You're going to profile all of your agentic AI. And if it deviates from that profile, red flag, take action. And these things can be corrupted. Identity and access management. Make sure that everything is being logged back to the SIM so you know all the actions that are being taken, so you can take all of the analysis and signals and then look and say, look, are they doing things that they shouldn't be doing? Leverage ephemeral credentials where you can. And then be ready at some point, if this thing goes and looks at HR when it should be, how would you, within minutes, revoke the access for that agent, shut that agent down? Things to consider. But this is no different than we do today with our employees. If I had an employee that was going rogue and I had an insider risk management profile and I saw them in an HR system accessing sensitive data, I'd quarantine their system or I'd shut off their access. This is no different than that. So, the governance framework. My suggestion on this, create a skills-based registry. You're going to see an explosion of agents in your environment. So you should understand what these agents are tasked with doing. What are they good at? What do they have as an available thing? So create a catalog where you can talk about, are you familiar with Alexa, right? All of the Alexa environments come with skills, right? I want my Alexa to sound like Sam Jackson, right? That's a skill I can enable in the Alexa marketplace, right? That's something I could get, and I could say these agents are going to have these skills. Salesforce, ServiceNow, all of these companies are going to have a massive army of agents that for a small fee you can enable as a skill in your agentic AI platform. Agent naming service. Create an understandable, semantically meaningful name for every agent, right? You shouldn't have to say, what does agent 1234 do? I don't know. Isn't it obvious? It's 1234. Create something that makes sense to you. Come up with a system for naming your agent so you understand at a glance what this thing is doing or what it's a member of. I'd further suggest that you come up with something that would be akin to blockchain, right? So you have something that is a cryptographically valid naming convention. So Ken Wang, Cloud Security Alliance, the greatest, he's come up with this idea of this decentralized identifier where you can create things like a blockchain identifier that would say uniquely identify that particular agent. So it can't be corrupted, can't be duplicated, can't be confused. It's unique to that particular identity. But pair that. So now we get back into, all right, so now we put it all together. I've got a skill set catalog. I've got a maturity model that says these AI agents are relatively mature and trusted. I can know what they're named, billing agent. I know it's bill.condoso.com, and its DID is DID agent XYZ789. But I can tie that back to what it does and what it's supposed to be a part of. So now I'm creating a catalog. Again, this is all in the idea of you have to be able to govern these environments. And there's going to be an explosion of these agents in your environment. So you have to be able to think about how would I want to know what they're doing, all those things. So the advanced concept, Ken Wang has put out a zero trust identity framework for agentic AI. It's a huge leap forward. I think it's a good idea. So here's the tech stack. So like we had for lions, tigers, and bears for Gen AI, the same thing exists here for agentic AI. You've got the NIST AI RMF that does specifically cover agentic AI. You got MITRE Atlas that talks about that. There is an OAuth top 10 for agentic AI as well. And then the Maestro framework that I mentioned before for agentic AI is a threat modeling framework for agentic AI. So here's the last thing, the cutting edge. This is the very newest. MCP, Model Context Protocol. This is a web browser for your agentic AI. You'll see things. If you're using things like Feedly, it comes with an MCP server. There's so many MCP servers out there now. And what you're doing is saying, hey, agentic AI, digital employee, open up a web browser and go out and find this information for me. What could go wrong with giving our digital employees full access to the internet and telling them to go wherever they want to find information? So just like we do for employees, we need to have controls on our MCP environments. Who's accessing our browser? Where are they allowed to go? What's safe browsing in terms of agentic AI? So these are the things that you'll see from Model Context Protocol. So all of these interactions, they could be looking at potential poison. So imagine you got an agentic AI that goes out to a website and there's a watering hole attack. But instead of being malware, it's got a prompt injection string to essentially allow that AI to send all of your local emails from your RAG data source out to the attacker. It's a possibility, right? Credential exposure. Well, what identity is being used to go out to the MCP server? It's essentially credential theft that you would have on any end user going out to a malicious URL. Supply chain risk. Where are these MCP servers hosted? Are they trusted? You guys all classify all of your URLs today as trusted or not trusted. These MCP servers should fall into the same profile. Tool compromise. We know that these tools are safe, that this tool hasn't been co-opted in some fashion. If you had a Feedly, MCP server, and our new URL stood up, feedlycom.com MCP server, would you know enough not to mistake it, not to get it wrong? And then visibility. We need to have full visibility. Whenever these things go out to the internet and they're browsing using MCP, just like we do today, we need to know what they're doing and where they're going. All right, these are some of the suggested references. There's a great course, Thinking Freely with Nita Farahani. It's an online course. She's a law professor. And believe me, if you learn this stuff, if you start to think about, I'm getting into AI and want to learn a little more about AI, your legal team will be contacting you. Should we allow this in contract? Should we be able to use these things? There'll be so many questions that you'll want to get involved with. So this is a great way to get involved. I'm looking today at, should we or should we not allow recording of messages? What about certain meetings? Is there a risk with recording those meetings? Is that transcript from Teams admissible in court? Not admissible in court? What do I need to do? Gradient Descent is a great Substack read about all sorts of probes. The greatest Ken Wang and his agentic AI Substack talks about lots of great articles. Omar Santos on Medium. The AI VSS is Ken's creation. It's an AI vulnerability scoring system. So this is no different than we already use today for vulnerability scoring, but this is specific to threats against your AIs. This is the AI VSS. And then obviously the threat modeling environment, that's coming on. I would expect that this is all going to expand. These tools are so new, but over time, somebody's going to take advantage of this and build it into a tool. Say you can use our threat modeling tool against Maestro. There's tons of books. I read a ton on this stuff. It's my hobby, and it's a passion. So these are some of the books that I've read and I'm actively reading, or actually they're on my list and they're being delivered soon. And then there's lots of podcasts, lots of great podcasts. So tons of sources. All right, we have a few minutes for questions. I would love to take some questions if you guys have any. And what I'll ask you to do is name what you do, and then tell me, what is your P of doom? If you haven't heard of this, this is a very popular concept. What's the probability that AI will kill us all in the near future? 100%? 10%? So if you ask a question, please give me your P of doom. 100%. Any questions? Randy. $100%? All right. Yep. Yep. So all of these models are stochastic processes. They're getting questions, answering questions, evaluating questions constantly. That runs in memory. All of these chaotic processes eventually break down. So the ability to stay coherent through these stochastic processes break down. They're still analyzing why this is and trying to come up with ways of improving this. There's an active project underway. I think OpenAI just set a record for 7 hours, for a full stack developer using their coding platform. It was able to stay coherent for something like 7 hours. That was ChatGPT 5. But the thought process is all of these processes are running in memory, constantly running mathematical backgrounds. At some point, the entropy in that system just gets too great and starts giving you garbage answers. But that's just the way they're built. They are essentially, when people think of hallucinations and AIs, it's a feature, not a bug. This is what they do. This is the power of these tools. They're able to creatively answer questions because they're able to put things that are not necessarily going to make sense together. Good question. Yep. Right. Other questions? Matt?
Matt Fouché, and my PhD was probably 1%. I believe a lot of people. Yeah.
All right.
I don't think it's going to tear their apart. My question's around, I believe in like governance is kind of the first step. So
Yeah.
I'm looking at like small and medium-sized businesses. As far as governing, we've seen things like on the open source side of being able to, say, assign tokens for certain projects. You can not only get ROI out of it, but you can provide a governance function.
Right.
Have you come across any solutions for small, medium-sized businesses or for your own business that kind of help get that whole thing started?
Great question. Are there any sort of governance tools that are out there? The closest thing I would suggest to you is there are AI SPM tools that are out there, but these are all relatively new. So I was mentioning Wiz has a great tool. So Wiz has, if you're managing a cloud environment and you're doing cloud development like Azure OpenAI, Google Vertex, or AWS Bedrock, Wiz will go out and discover all those assets and then actually look at what models are being used, what frameworks are being used to connect all of that and do it dynamically in real time. It has a model scanning feature. It's a great way of looking what actual AI is in your environment, and I've used it actively. So when I've talked to development teams, I'm like, hey, have you actually put human in the loop or token rate limits on your particular model that you're developing? Oh, I'm not doing AI. I'm like, here it is, using this model. Oh, that's our research group, and yeah, they did a small instance of that. That's only available if you're using cloud tools, right? Sneak has something coming out. They just bought a company where it's going to be, if you have Sneak running in your environment, it can look at your code base, and if Sneak says, hey, wait a second, Matt's using LangChain, or he's using WeVA, that must mean he's using AI. Let me go out and see if I can discover what he's doing. So it'll automate that to some extent, but again, that's only if you've got Sneak plugged into your environment. But there's no tool that today, like a CMDB, will go out and auto-discover your environment and look for AI in your environment. Other tools that can do some of these things. So there's a tool called Zenity, which will go out and look at your agentic AI landscape. This is a very Microsoft thing. So if you guys aren't familiar, you guys are all familiar with Microsoft Copilot, but Copilot Studio will let you develop agents. And Zenity will allow you to go out and discover all of your Office 365 tools that are leveraging Copilot Studio and other things like that. But again, there's no one tool to solve it all today. So that is, it's definitely an evolving space. Great question. Other questions? Please. What's your P of Doom?
Probably like 20%.
All right.
As more public content is generated by AI, is there a concern with kind of a snake eating its own tail in terms of content generation?
Yeah.
So dead internet theory is the first thing that comes
Yes.
to mind? Yeah. So
Yes. All right.
What your thoughts are.
So are we going to run out of content to feed our AIs? And the short answer is, it's already happening.
Yeah, and OpenAI, I think, is already purchasing
Right,
proprietary data from
that's right,
companies
right.
to try to mitigate that.
So, a couple things. Some of the reading that I'm doing about the next 5 years, and this is the time scale is 5 years before we get to AGI. Whether or not we do or not, that's an open debate. But when we talk about AGI, artificial general intelligence, human equivalent AIs, it all depends on some manufacturer of synthetic data. So at some point, we're going to run out of real world data to feed these things from the internet, digitized data. We'll have to create new data sets to feed into this, all of which is very problematic. I tend to think there's an unexplored wealth, and I think the next big breakthrough is going to be physical AI. So think about this. If I've got a dangerous environment that I want to send an employee into, changing out a high voltage wire, do I want to send the employee into that? Or could I put an AI into a robotic entity that would see, touch, sense, and I could have the robotic AI do that for me? Physical AI is something that is evolving really quickly. And I think, if you think about, I think a lot of these things is like children, right? AIs are just like children. How do children learn? They get interacted with and they learn mommy, daddy, all the things from your interaction. But they also learn from looking around the world, touching, seeing, sensing. All that physical data is what I think is probably going to be the next frontier for us, enabling all these AI systems to interact with the real world and learn from the real world, just like we humans do. It's going to be able to see things, touch things, and interact, and then get a sense of, it'll get smarter and smarter as it interacts with the world. And there's hopefully an unlimited amount of data in the world for it to interact with.
That happens, my P of Doom will go up.
Oh, yeah? What would your P of Doom be then?
50, 70.
Yep. Great. I think we've got time we've got a 10-minute grace period, but if you have any other questions, I'm happy to answer them, and talk with you guys afterwards. Thank you.